Wow, that video gets me every time. Hello, everyone, and welcome. I'm George Baker with Rail Safe Training. Thanks for joining us. Today's session is called The Reality of Railroad Safety. And that word reality matters because in safety, perception doesn't matter, only reality does. And as Gordon Graham says, if it's predictable, it's preventable. If it's preventable, it's defendable. And here's the truth. Most railroad incidents aren't surprises. They are repeat risks, unclear ownership, assumptions instead of communication, mixed rules inside customer facilities, and that gray space between railroad and plant responsibility. That's not bad luck. That's known risk. And when we know the risk and don't act, we're not unlucky, we're unprepared. If you're dealing with it, chances are someone else is too. The reality of railroad safety isn't about having more rules, it's about asking harder questions. Where are we exposed? Who owns the risk? What are we tolerating today that could injure someone tomorrow? Because safety leadership isn't proven after the incident, it's proven before the incident. In the conversations we choose to have, the standards we choose to hold, and the risks we choose to eliminate. And that's what this program is about. Seeing risk clearly, owning it fully, and leading before it leads us. And we couldn't ask for a better group to guide us in this conversation. You'll be hearing from Russell York, a nationally recognized safety professional focused on turning known risk into proactive leadership. Lanny Dyvig, a respected railroad leader who understands what safety looks like when decisions matter most. And Andrew Johnston, the seasoned operations safety leader who bridges policy with real-world execution. Between the three of them, you're not getting theory, you're getting field-tested reality. So as you listen today, don't think about policies, don't think about procedures. Think about this question. What risk do we already see, and what are we going to do about it? Because in railroad safety, the goal isn't to react better, it's to lead sooner. And with that, it's my privilege to introduce our first speaker, Russell York. Take it away, Russell.
Hey, thank you, George. Good afternoon. My name is Russell York. The reason why I'm here today is simple: to help you succeed with your rail safety program and basically make sure every worker goes home safely. Today, we'll be discussing statistics from various sources, such as the Department of Transportation and from the Switching Operation Fatality Analysis Group, or SOFA. These are the reported Class 1 and short line fatalities. We're going to use that data and combine it with our own internal industrial audits and paint a picture of the risks we're seeing in the field. We'll also discuss best practices for driving meaningful change in rail safety culture, what's working, what we're seeing in the field, and how those lessons can be applied in your operations. This historical data, if you can see this report from 1889, reflects where we are over 100 years ago and where we're at today. The historical report shows rail operations have always carried significant risk. And although the technology has greatly improved, the need for strong safety practices remains just as important today. This report indicates the improvement over a century. However, each fatality highlights what ongoing attention to safety is critical. This study, funded in part by the U.S. Department of Transportation, found that rail accident fatalities were far more common during switching operations. Specifically, as you can see, 72% of fatalities occurred during switching operations compared to just 28% during mainline operations. Because the majority of rail fatalities occurred during switching operations, we'll be referencing findings from the SOFA analysis. This is also known as the Switching Operation Fatality Analysis Group. They're brought together by a group of labor, industry, and regulatory representatives to help identify common causes of switching-related fatalities and also to develop recommendations to prevent future deaths. SOFA continues to review fatality issue safety concerns. For example, a 2020 alert that you can see here highlighted multiple incidents where employees were crushed in close clearance areas, an issue that remains the leading cause of death identified through SOFA's analysis. Over a 20-year period, the SOFA group reviewed 179 fatalities related to railroad switching operations. This data provides a strong foundation for understanding where the greatest risks exist and where prevention efforts should be focused. In this analysis, fatality groups were grouped by the most common causes of accidents. This helps identify where the risks are the highest. One key takeaway, as you can see here, is the importance of providing inexperienced employees with adequate on-the-job training. We'll now peel back the onion skin on each of these findings and take a look at the risks, starting with the highest risk, close and no clearance accidents. As you can see, close no track clearance accidents account for 25% of fatalities. We found through our own internal audits that 70% of close clearance accidents and areas are not properly marked. These are a couple of examples of close clearance areas and the inherent risks. A question you can ask yourself, in your industry, do you have proper signage similar to something like this? Do you allow employees to ride in close, no clearance areas? Can you define what a close or no clearance area is? As we move on to track clearance exposure occurs when equipment is not properly parked clear of adjacent tracks, putting employees at the risk of being crushed. As you can see in this diagram, we have a location marked where the fouling point is. That's where the two cars will actually physically meet. And the clearance point, the recommended location where you park cars beyond. This can happen to someone riding on the side of a rail car or to an employee on the ground as cars pass or couple. Tragically, fatalities have occurred simply because equipment was not left in its proper place. And these type of incidents continue to happen today due to ongoing non-compliance. As you can see from these visual indicators, any location where two tracks come together create the potential for close clearance or track clearance exposure. That's why it's critical to educate employees on how to recognize these hazards and to understand the procedures to follow when you encounter them. A key question to ask whether your close clearance areas are clearly marked and properly signed. Again, close clearance is just one of the many critical items we evaluate during on-site risk assessment and facility audits. We have found through our own internal audits that 75% of tracks are not properly marked. Are your track clearances properly marked? Do you know how to properly measure and mark the track clearance locations? Inexperienced employees represent the second largest category in these incidents. That makes knowledge sharing and strong on-the-job training critical. If you're an experienced railroader, it's important you share your knowledge. Tell the people what you know. If you're unsure as an employee, ask questions. Supporting and seeking quality theory, classroom training, and practical on-the-job training plays a key role in reducing risk and preventing these type of injuries. Industry hazards come in at 21%. It was reported 9 employees were killed in collisions with motor vehicles or riding equipment over road crossing. These incidents highlight the importance of recognizing and addressing roadway hazards. To reduce this risk, hazards must be reported through established procedures and followed up with corrective action. Good job briefings discussing the risks are important. Employees should give coworkers a heads up when operating conditions change or when entering unfamiliar industries. Most importantly, employees must be empowered to stop work when a hazard puts a crew at risk. Obviously, safety must always take priority over completing the task. Inadequate job briefing comes in at 20%. When conducting a job briefing, it should be done face-to-face whenever possible. with clear expectations and confirmation that everyone understands. If conditions change, additional job briefings are necessary. This can be done face to face or via the radio. Effective job briefings rely on effective two-way communication. Ask questions, firm understanding, make sure every crew member is engaged. We have found that a majority of human factor incidents involve some type of communication breakdown. Employees struck by mainline trains come in at 17%. These risks can be reduced by using multiple warnings, planning safe roll-bys, and dismounting on the field side, and conducting a job briefing before dismounting. Folks, this wraps up the risk and incident data portion from my portion of today's discussion. We've talked about where the hazards exist and why they matter. Now I'd like to shift our focus to the physical side of rail safety, track and track structure. To that, I'm pleased to introduce my colleague, Lanny Dyvig, who will walk us through track structure fundamentals and key safety considerations related to track conditions. Thank you. And Lanny, I'll turn it over to you.
Thank you, Russell. Good afternoon. My name is Lanny Dyvig. I'm here to provide you with the information, hopefully, that will help us become more aware and potentially identify detrimental track failures and the impact that they might have on our operation. As Russell has mentioned, we all share similar challenges. By sharing our knowledge, we all help to educate you, your team, and we'll be successful at meeting some of those challenges head on and hopefully avoid the delays to your production. Let's face it, moving rail cars is a dangerous situation, dangerous job. And what we need to do is help to reduce risk as much as possible by doing that through appropriate education and practice. So I'm going to start with industrial track inspections and what they can do for us. Regular railroad track inspections are more than just a safety requirement. It's just like inspecting and maintaining things like your personal vehicle. If we stay ahead of it, we're going to avoid future problems. They're a critical component of operation continuity. By identifying and repairing defects early, you protect your crew from injury, you prevent the devastating costs of derailments, and you keep your schedule on time. So some of the strategic benefits that we see, or that we should all see, really, taking a proactive approach to minor wear, such as rail defects, tie decay, and drainage issues. This allows you to shift your reactive emergency repairs to some sort of planned maintenance. This foresight usually ensures major projects are integrated into your long-term capital planning and scheduled during existing outages to minimize the disruption to your production. Those strategic benefits can include many types of successes like catching failures, such as broken rails before they cause accidents or injuries. With proper maintenance, we are extending the infrastructure and avoiding premium costs of emergency fixes, eliminating unexpected delays to keep your supply chain moving is what our desire and your desire is. Regular track inspections can identify a multitude of railroad track structure issues. We can detect flaws like cracks, worn railheads, switch point damage, or frog defects. Also, with track components, we can identify loose or bent fasteners, missing bolts, decaying ties, hard to throw switches, incorrectly placed derails, and signage. The track geometry is always key. Obviously, we want to make sure we have correct gauge. We can identify incorrect gauge, the distance between the rails, misalignment or uneven settlement, which is often indicated by standing water. These regular track inspections also identify other observed or other hazards in the area around the switches on the track. The weeds that are growing in and around tracks and walking paths are ensuring that you have appropriate clearances for track to building structures, and appropriate signage for warning of those clearance issues. What regular inspections also can identify that vegetation that we talked about, right? It will keep you to or avoid tripping hazards, keep people from falling while they're trying to throw a switch, for example. Inspection standards, that's something that we always have to talk about. The FRA has statutory authority to issue emergency orders if industrial or plant track conditions pose a possible death or injury hazard. While industry or plant railroads are excluded from the compliance, the regulations should be used as a guide to ensure that their tracks are capable of carrying rail traffic safely. The Railroad Administration, we call it the FRA, does not require regular inspections of industrial tracks, nor must inspections be performed by certified track inspector. And what I mean by this when I say does not require, that pertains to privately owned tracks like yourselves, the people that operate within their own private facility. However, keep in mind, the industrial tracks that are used by servicing railroad and those that are near bridges or carry hazardous material cars must be maintained to Class 1 standards. The FRA recommends that all plant industrial installations meet FRA Class 1 standards. You can find this in the FRA Standards 49 CFR Part 213. If your tracks are not maintained to regular standards, the servicing railroad will not be able to safely service your facility, possibly resulting in suspension of service and or additional tariffs. So when you're in doubt as to the condition of a track component or structure, a qualified track inspector should be consulted. Keep in mind, Rail Safe Training recommends that tracks be inspected at least twice per year. If you were working for a Class 1 railroad, industrial tracks are required to be inspected monthly. But again, that is not covered under privately owned tracks. So we recommend, again, at least twice per year. Let's talk a little bit about the track structure. So those of you that are maybe not as aware or maybe haven't spent as much time out on a track can get kind of an idea about what it really looks like. Railroad tracks are a system of components that are designed to provide a steel road for rail equipment. The rails are steel beams on which on-track equipment travels. The weight of this equipment is distributed from the rails to the tie plates and then onto the cross ties. The cross ties are then supported by ballast between and under the ties. And on the ends, they form what we call a shoulder. The weight is then transferred to the sub-ballast and the subgrade, hopefully giving you a nice, even, smooth ride. I'm just going to go through the following slides just fairly quickly and kind of give you some examples of rail defects that we found, surfacing defects that we found, things that we actually have taken pictures on sites that we have all inspected over the course of several years with rail safe training. This is called the vertical split head failure. The dark streak that you'll notice in the first stage of development, that's where it starts. That break is very obvious, right? Once it breaks off. The development of that first stage can be seen on the top of the rail on the left side of the picture. If you'll notice, you'll see the smashing and kind of the mashing on the top of the rail. When you have a little bit of training and experience, you begin to notice that on your rails, and hopefully you can stay ahead of a break like this that could cause a derailment. Rail burns, which we seem to have quite a few of in some of these private facilities. And I think it's probably attributed to the fact we maybe don't have quite the experience in operating and pulling some of these large number of cars that are very heavy. And so we begin to spin out, or maybe we don't have the sanders working on our trapmobile or our locomotive. It burns the top of the rail. Anytime you get a burn that's more than 1/8 of an inch deep, it begins to cause fractures. These fractures then can end up going down through the ball of the rail and then break the rail as it gets pounded on by the rail cars that are coming over the top of it. Here's a very good example of a badly burned rail, and this is all from wheel burns. You can see where the wheels on both sides of these tracks have been basically ground down, and anything, like I said before, that's deeper than 1/8 of an inch has to be replaced. It is just highly recommended because we know for sure, number one, it's going to be a very rough ride and we're going to get a lot of pounding, but eventually because of that pounding, we are going to get broken rails. Here's another example of a rail defect. This is called the mismatched joint. This mismatched joint, anything over about 1/4 inch, needs to be repaired because of the pounding. you'll notice in this picture that not only are we having problems with mismatched joints, but look at the mud and the dirt that surrounds this. We can't even tell if the cause is a broken rail or a broken bolt inside the angle bars, or what the cause might or may not be. The picture on the right shows a piece of rail that was completely broke out. It probably had some kind of a wheel burn or fracture, and then it broke just what, about 6-7 inches away from the joint, and then we end up having a piece of rail that can be bounce right out, cause another derailment. Rail joints. Look at this. This is a mashed rail. Look at the beating that the top of the ball of the rail is taking from the locomotives and or the track mobiles and or the rail cars running over the top of it. What it's done here is it's been pumping and pounding so much that it broke the angle bar. So now we don't have anything holding that piece of rail together, or those two pieces of rails together. If you also notice, look at the gap between the plate and the base of the rail. See the gap in that? That is because those ties are not surfaced and tamped right up against the bottom of the rail. It's probably pumping in this area, more than likely, maybe a wet area that we have poor drainage. So this needs attention. Here's an example of a bad order frog. As these frogs begin to deteriorate, those points begin to break out. As those points break out, now it becomes a problem where the wheel could go down the wrong track. So we would have a situation for one set of wheels is going down the track far to the right, and the next set of rails or wheels end up going down on the track to the left. So then we end up having a derailment. A very critical situation. If you'll notice, there's probably some surface issues in this location too, because look at the mud and water situation that you see all throughout that track. So it needs to be tended to, corrected, to avoid any injuries or derailments. Of course, if you find a rail defect and you discover one, you should immediately reduce speed over the defect until you determine what the problem is. Continue operations over the defect only if it's safe to do so. Repair the defect as soon as possible. Take the track out of service if necessary. Again, if you're in doubt as to the severity of any defects, always take the safest course of action. Remove the track from service and contact a professional track inspector. Here's an example of wide gauge. Notice that the tape measure shows 58 inches. The proper gauge is 56.5 inches from the inside of the ball of the rail to the inside of the ball of the joining rail. We allow in class 1 10-mile-an-hour tracks a gauge of 56 inches, which is a half-inch tight, to 58 inches, which is about 1.5 inches wide. In this particular case, we're right on the outside of the limit for the wide gauge. Now, you would think at first glance that we're okay here, but look at that plate. Look at the base of the rail and look at that plate. That is that gap there is an indication that this rail is moving under load and it's moving to the outside, which is also an indication that we probably have a rotten tie and the tie needs to be replaced, the gauge needs to be corrected. So those are the kind of things that we find every time we go out and do inspections. Here's an example of some surfacing issues, right? So we have obviously probably some water problems here, some drainage issues. Water is sitting in this track. It's causing the ties to rot. All the rock and the mud and the dirt is starting to pump as the rail cars go over this rail, and it starts to pump all that dirt and mud up in and over the top of the ties. Then we start having a problem with ties that are deteriorating, and then they're not causing gauge and tight gauge, and then we have derailments. Here's another example of a situation where those ties are not holding gauge; they're falling apart. By rules, a class 1 10-mile-an-hour track, you'll notice that there's 3 bad ties in a row, and then 1 good tie on both sides of that. That falls into the standard of saying that's an okay situation to have, because you have every 4th tie is good as long as it's holding gauge. But it is also a situation where you need to replace some ties because you do not want to open yourself up for a derailment and or an injury. 2 more pictures of situations where we have drainage issues. You can see the wet, muddy area on the left, and up on the upper left-hand corner, you can see where the water is draining and making almost a channel in the dirt and the rock over there on the left-hand side. That picture on the right is another situation, like I just showed you a couple slides back, where the rail is pumping and all that mud and dirt is pumping up. Both of these situations where we need to address the poor drainage issues, and we need to get some equipment in there to surface this track and get it back up out of that mud and get it level and smooth. We at RailSafe Training offer an industrial track inspection course. The course is for individuals and companies that want to train their employees to be able to evaluate the quality of the track structure and also to perform their duties safely. It contains information and instruction needed to work in a rail environment and perform duties without injury or damage to your equipment. The course is designed to give a general understanding, I repeat that, a general understanding of the components, the structure, and the purpose and condition of industrial tracks that have a maximum operating speed of 10 miles per hour or less. This will help identify defective conditions that are or may become detrimental to the safety of the facility. Our track inspection course is for industrial facility use and does not qualify you as an individual as a certified track inspector. So you cannot go outside of your private little industry area and become a track inspector. You have to have specific requirements on class 1 and class 2 railroads to be able to be a certified track inspector. This particular class teaches you how to evaluate and inspect your own private track. For further information and details on this, you can go again to the federal regulations and look at 49 CFR Part 213 and 214 if you want more details. That ends my presentation for the track structure inspections, and I'll go ahead and hand it over to Andrew.
Thank you for that bit on track inspection there, Lanny. Really appreciate it. Again, my name is Andrew Johnston, and we're going to be talking about RailSafe risk assessment statistics. Where do these statistics come from, first off? Well, as part of the services that we offer here at RailSafe, our risk assessment service, we go onto a site. We have a 108-point inspection that we perform, detailing both physical plant items such as track structure, switch safety, signage, close clearances. We're looking for the physical hazards that may exist. We also look at operational behavioral risks that are present. So are folks utilizing blue flag and red zone properly? Are they protecting shoving moves properly? Are we communicating well? All of that is covered. So we took a 1-year period, over 100 risk assessments, and extracted the statistics from that you see here from those. We'll see some pretty enlightening and I would think pretty alarming information over the next few minutes here. But first, I want to start off with what is considered by many folks in the railroad industry to be a worst nightmare scenario. And that, folks, was a runaway rail car. If you look closely, you could see that it was a placarded hazardous material tank car. What happened there? Well, that car was not properly secured within a facility. It was left unattended and not properly secured. It escaped the facility and proceeded to move on the main line by itself. Securement. How do we secure cars properly? Well, we secure cars with handbrakes. Handbrakes and handbrakes only are used to secure cars. We don't rely on the air brakes of the cars to hold them in place. We must use handbrakes. Taking a look at our statistics that we gathered in these plant railroads that we visited, we're seeing that 61% of facilities were not properly securing their cars. And at approximately 38% of those facilities, grade was a factor in the handbrake count. Looking at some overall statistics that we gathered, we can see a pretty wide spread of failure rates here. All still not where they should be. From 79% of facilities having tripping hazards, substantial tripping hazards present, all the way down to 21% with crossover switches not lined correctly. A great deal of room for improvement in many of the facilities that we visited. Next, let's talk about motive power failures. What is motive power? So to get the cars moving that we need to move within a facility, we have to use either a locomotive or a rail car mover. Those are the two most commonly used forms of motive power. Looking at locomotive and rail car mover failures, they were not secured after use 55% of the time. How do we secure a locomotive or rail car mover properly? Well, we set it up against cars that are already secured. We would apply the handbrakes on those, make sure it doesn't run away from us when it's left unattended. All those things factor in to that failure rate. The whistle or horn was not used when initiating movement, approaching walkways or crossings 50% of the time. And keep in mind, when we are going over a public crossing at grade, this becomes a liability issue. We need to be utilizing the horn with the lights on bright. That could become a personal liability issue. Brakes were not tested 25% of the time on the motive power. We want to make sure we are able to stop that motive power in a timely fashion. The brakes are operative. 25% of facilities were not testing their brakes. Failure to protect shoving movements. Well, what is a shoving movement? When cars are handled ahead of the motive power, when the operator cannot see the leading end of a movement, we must have somebody on the ground or riding the car observing the leading end of the movement, so that movement doesn't run into anything, doesn't run off the end of a track, doesn't hit somebody who might be standing foul of the tracks. A very, very important and commonly used railroad procedure. Taking a look at the failures here, the route was not inspected at 18% of the time. The lead end of the shoving move, this is, again, very important part of this puzzle. 33% of the time was not kept in view. Speed was not controlled to stop within 1/2 the range of vision at 15% of the time. And the operator did not stop in 1/2 the last stated distance at roughly 31% of the time. Again, all of these little bits and pieces here are critical to making sure that we are protecting shoving movements properly. Fouling a railroad track means being close enough to a track to be struck by a moving train or on-track equipment. 30% of employees observed did not stay clear of the tracks. So when we talk about fouling a track, we see a picture here of a guy walking down the center of the tracks. We see this far too often here at RailSafe during our risk assessments. We also will see people walking on the tie butts or standing on the tie butts, lingering near the tracks where they could be struck by on-track equipment. All of these very dangerous behaviors and habits to get into. As part of our training, we teach when you don't have to be in the rail yard, stay clear of the rail yard. Always be conscious of where you're walking, because the car can get away from you. It can become a runaway car, and there have been many serious injuries and fatalities in the railroad industry due to people being struck while fouling the tracks. Some statistics on walking in the rail yard. 68% of the people at these facilities did not allow 25 feet around the end of standing equipment. Why is that important? Well, if a rail car were to move or jump suddenly, say it's impacted by another piece of equipment, and there is a person walking directly around the end of that rail car, let's say right around the knuckle to get from one side to the other, or maybe they're in there performing some work. If they do not allow themselves 25 feet of room, they're going to be crushed, plain and simple. They're going to be crushed, end up under the wheels, a tragic scenario. By allowing ourselves 25 feet of room, we give ourselves a zone of safety. If a car jumps suddenly, moves suddenly, we're giving ourselves some time to get out of the way. This goes hand in hand with 58% of people who did not allow 50 feet between two standing pieces of equipment. Two pieces of on-track equipment need 50 feet of room in between them for you to cross safely between due to the same factors. If one of those cars were to jump suddenly, we want you to have room to safely get out of the way. And just as we were taught when we were growing up as children, before we were getting ready to cross a busy street in town, what did our parents tell us? Look both ways. We do the same thing in the rail yard before we cross a track. We look both ways every time, make it a habit. 25% of employees at the facilities we visited were not looking both ways. And going back to fouling the track, 37% of facilities had a failure rate where people were not staying clear of the tracks, fouling the tracks when unnecessary. Initiating movement failures. After we couple rail cars together, we want to stretch them to make sure that we have that cut of cars solidly together. If we fail to do this, it's putting a person who goes in between those cars to work on them at risk. We also may have a runaway car scenario. If we let the brakes off and the cars aren't coupled properly, we may have runaway cars getting away from us. So we stretch that equipment every time we couple equipment together. Couplings were not stretched in just over 18% of observations. And something as simple as operating a switch. Even though this is one of the most commonly done operations in railroading, something as simple as operating a switch can have drastic and deadly consequences. There have been many severe injuries and even fatalities due to improperly operating a switch. What you see here are little bits and pieces of the switch operation process that are vital to doing this safely. And lastly, I'd like to hit on here that we are pulling from these assessments is blue flag protection. This is commonly known as the lockout tagout of the rail industry. In blue flag, we have the notification, which would be the blue flag. That would be the tagout portion. And we also have physical protection. In this case, we have a locked derail in derailing position. This could also be a switched, lined, and locked to prevent access to a protected track. That would be the lockout portion of blue flag. And why do we have blue flag? Well, it is to protect people who are working on, under, or around on-track equipment within a protected area. Think of somebody working on a car, servicing a rail car. Perhaps they are in a loading area, loading chemicals or product. That's where we would see blue flag protection in play. And look at these statistics. I think this is the most alarming set of statistics that we have found, just my opinion, but 70.8% of facilities that we visited, the blue flag was not placed properly. The notification was not in place. And 91.6% of facilities, physical protection was not in place. They did not have the lockout portion in effect. Now, what I'd ask you folks to do, remove yourself from thinking about the rail yard for just a minute. Put yourself back into the four walls of your production area, your facility where you make your product. Imagine if you had a 92% failure rate on lockout tagout within that area. What would be the repercussions? It's not acceptable there, and it's not acceptable in the rail yard. And a 92% failure rate is far, far too high. Implementing a safety culture. We need to identify and mitigate risk. Identify potential in the workplace through risk assessments, a service that we at RailSafe offer. We just went through some of those statistics. Assess the risks associated with each unsafe behavior. Develop an action plan, whether training or observations, to eliminate or reduce the risks. And implement the training plan or observation plan and follow-up measurements. The direct and indirect costs of an incident. You can see here a picture of the Lac-Mégantic Quebec derailment. This happened back in 2013. It was one of the most, in my opinion, tragic incidents in modern rail history. Definitely one of the most tragic in North America. This was due to a securement failure along with other underlying issues with the train, but could have been avoided for sure. Looking at the costs associated with this, last information that I saw, over $600 million in claims and remediation costs, and most tragically, over 40 people lost their lives as part of this incident. Large portion of Loch Megantic was also burned to the ground. So things to think about. What could be the result of a runaway car, especially a hazmat car, gets out on the railroad main line? It may end up creating a scene that looks just like this. And think of the derailment restoration costs. It's quite easy to spend $30,000 to $250,000 per hour, depending on what type of derailment we're looking at. It can get very substantial very quickly. Also, something to consider is rail car damage. $20,000 to repair a car on average, a typical cost. Now, we also need to think of the social impact to plant rail yard accidents. We live in a world where social media is in constant use. Every person is carrying around a phone with a camera. Every person is a reporter to some extent, and narratives can easily spin out of control. You don't want to be the company that haphazardly handles hazardous material. One incident could change the public's perception, and the perception is the truth. And with that, I will hand this presentation back over to George Baker to finish us off. Thank you all very much.
Thanks, Andrew. Thanks, team. As we wrap up today's conversation, I want to take a moment to bring us back to why this matters. Railroad safety isn't about intent. It's about what actually happens when the pressure is on. It's about the risks we already see, the shortcuts we're tempted to tolerate, and the gray areas we leave unresolved. Remember, as Gordon Graham says, if it's predictable, it's preventable. If it's preventable, it's defendable. Most of the risks we talked about today aren't hidden. They're known. The question isn't whether we recognize them. It's what we're willing to do about them. Safety leadership isn't proven after something goes wrong. It's proven before the incident, in the conversations you choose to have, the standards you choose to hold, and the risks you choose to address. So as we close today, I'll leave you at this. Most incidents don't come from what we don't know. They come from what we knew but didn't act on. The reality of railroad safety is this: leadership happens before the incident, not after. If today's topics interest you, please now go to your email and type in info@railsafetraining.com, or you can email Chuck at railsafetraining.com or info@railsafetraining.com. And in the description, write in what interested you and what you'd like more information about. If it's track inspection, write track inspection. If it's training, mentorship, rules, any other issues you'd like more information. In the body of the email, please be sure to have your contact information so a rail-safe training professional can get back in touch with you. On behalf of the rail-safe training team, Russell York, Lanny Dyvig, and Andrew Johnston, thank you for the work you do every day. Stay safe, lead early, and everyone goes home. Thanks, everyone.